All right, so we're going to look at some polynomial stuff here. So, start with expanding. So there's two ways we can expand the brackets. We can use something called distributive property and something called an area model. So looking at this polynomial here, okay, we've got this trinomial, which means it has three terms, 1, 2, 3 terms, and this binomial, which has 2. What makes a term is whether or not it has a variable attached to it or no variable attached to it. And that variable can be an x or an x squared or an x cubed or an a or a b. So this has an x squared attached to it. This has an x. We can't combine those. Those are not like terms because one is attached to an x squared and one is attached to an x, okay? So that's why they have to stay separated. So when we do this multiplication, if we use an area model, it's gonna look something like this. You're gonna have an x and a -3, and then you're gonna have an x squared, a 2x, and a -5. Okay, so we set this up. So basically we're gonna do all the individual multiplications, and then we're gonna add them up. So x squared times x, so this would be x squared times x. Oh, can't see that, hold on. So erase that, let's try that again. So x squared times x. Well, think about what x squared is. That's just x times x. And then another one is just x cubed, okay? So x cubed, -3 multiplied by x squared, -3x squared. X multiplied by 2x is 2x squared. -3 times 2x, -6x. X times -5 is -5x. -3 times -5 is +15. So if we look, there's only one x cubed term. So equals x cubed. X squared, we've got a -3x squared and a 2x squared. So if we add those together, we're going to get -1x squared, which we can write as just -x squared. If we look at our x's, we have a -5 and a -6. Together, that's -11x. And then our constant or our term with no x. So there is our answer using the area model. So this is the area model. So using the distributive model is more algebraic. So x squared plus 2x minus 5, x minus 3. Sorry. Okay, so what we have to do is each term in the first polynomial needs to be multiplied by each term in the second. So we start, and I'll use some arrows here and I'll get rid of them in a second. X squared times x, and then x squared times -3. So that's going to give me x cubed, and then -3x squared. Okay? So then we're going to go next. So now we're up here. And this needs to be multiplied by each one. So 2x times x, 2x squared. 2x times -3, -6x. And then the last one, the -5, needs to be multiplied by each. Okay? So now -5x and plus 15. Now we combine any like terms. So the x squareds get combined, the x's get combined, and we'll end up with the same answer. X cubed minus x squared minus 11x plus 15. And that's done using the distributive property. Okay, so this is our expanding of polynomials. All right, this one, same idea, okay? I find with the really big ones, sometimes the area model is actually easier than doing the other model. So if I put, and again, it doesn't matter which one goes on which side, but if I put x squared, -20x, 25, and then over here I put 2x squared 9x minus 14, and I build my area model. Right, here we go. Sorry, my lines aren't very straight. There we go. So then we just go through. So 2x squared times x squared is 2x to the power 4. 2x squared times negative 20. Negative 20 times 2 is negative 40. X times x squared is going to be x cubed. 25 times 2x squared is 50x squared. All right. X squared times 9x is 9x cubed. Negative 20 and 9 is negative 180 x squared. 25 times 9 is going to be 225x. X squared times negative 14, negative 14x squared. 20 and 14 is going to be 280. Yep. So positive 280 because it's two negatives. So 280x. So there's an x there. And then 25 times 14, that's going to be 350, and it's going to be negative. Okay? So we do all of our multiplications, and then we're going to take our x to the 4, which there's only one of. 2x to the 4. Any x cubeds, so 1, 2, and that's it. So 9 minus 40 is going to be negative 31 x cubed. Then we take our squared terms, which there's 3 of them. So 50 minus 180 is negative 130, minus another 14 is negative 144 x squared. Then we take our x's. So we've got 225 and another 280. So that's 505x. And then our negative 350 at the end. So there it is using the area model. Kind of break it down and set it up like that. Makes it a little bit easier to organize all the terms at the end if we do it with an area model. All right, so the next topic is factoring. So let's zoom out here. We'll zoom in down here. Zoom out with some more. Oops. How do I drag here? Oh, there we go. Okay, so let's come in here on factors. So what do we mean when we talk about factoring? Well, we're talking about finding the things that multiply together to make this. So in essence, when we talk about factoring in a simple term, we take the number like 18, for example. Factoring 18 is just looking at all the different number combinations that multiply to give us 18. So 1 and 18, 2 and 9, 3 and 6, 6 and 3, 9 and 2, 18 and 1. Not that we need to duplicate and come back over, because multiplication works the same both ways. Okay? But this is factoring in a simple sense. We're talking about factoring a polynomial. It gets a little bit more complex than that. So there's a standard practice that we can follow here, which is by looking at the term for the x, or the x coefficient, and looking at the constant term, we can determine some possible factors. So it's important to recognize whether or not what we call the leading coefficient is 1 or something other than 1. If it's 1, then we can follow a pretty simple practice. We're going to look for two numbers that multiply to give us 36. But that also, add to give us negative 12. Okay? So this works when we have a leading coefficient of 1. So let's think about numbers that multiply to 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, no 5, 6 and 6, and then we're going to start repeating. Now it's also important to recognize that we're multiplying and we're getting a positive result, which means there's also the case where we have all of these but negative on both sides. These also are going to multiply to give me a positive 36. So we can add those to our list here. So we're looking from this list for two numbers that will add up to negative 12. So 37, 20, 15, 13, positive 12, that's no good. Negative 37, negative 20, negative 15, negative 13, and right here at the end, negative 12. So these are going to be our two factors. Now, because this is a leading coefficient of 1, we can jump right into our factored form. Okay, but just before I do that, I'll just show you the breakdown. You're essentially taking that middle term and you're going to split it into its two parts. So it's going to look like this: x squared minus 6x minus 6x plus 36. And then we're taking that and we're splitting it into the factors x minus 6, x minus 6, or x minus 6 squared. So this is called the factored form of that polynomial. Okay, and I can only do that last step because these factors happen to both be the same. They're both negative 6. Okay, so that's why we're able to do that. So let's jump down and look at one where the leading coefficient is not 1. All right, here we go. So in this one, bring that over here and keep it. There we go. Okay, so in this one, we've got a leading coefficient of 2. So this one's a little bit different approach, but not a crazy different approach. So 2x squared minus 28x plus 98. Now, when you have a leading coefficient that is not 1, the first thing you should do is look for what's called a common factor. So look and see if everything can be divided by the leading coefficient evenly. So when we're dividing by 2, we're looking for even numbers, and they're all even numbers. So what we can do, we can actually just factor out the 2, leaving us x squared. 28 divided by 2 is 14. 98 divided by 2 is 49. So this is great because now we can take this and we can factor it the same way we did the last question. Right? We can do two numbers that multiply to give 49 and add to give negative 14, which is going to be negative 7 and negative 7. So we can write this, or x minus 7 squared. Okay? So that's going to work great. Let's say we didn't notice that though. Let's say we got here and we didn't pick up on the common factor. So what can we do? Well, we can still deal with this. So remember before, we would take our constant term, and that would tell us what our possible factors are. If this number is not 1, we actually have to multiply our leading coefficient and our constant. So 2 times 98 equals 196. That number is where we're going to be looking for our factors. And we're going to be looking for multiplying to 196 and adding to negative 28. Okay? Now, finding factors of 196 is not going to be super easy. You've got 2 and 98. We know that much. Finding factors beyond 2 is going to get a little bit trickier. And you're going to have to play around. The easiest way to do it is actually use like a factor tree, where you would do something like 196. Oops, sorry, can't see that good over there. You would do something like 196 divided by 2 is 98, divided by 2 is 49, and that has the two prime factors of 7 and 7. So really, we don't have that many factors here. We have 2 times 98, 2 times all of these, which is 2 times 98. We have 2 times 2, which is 4 times 49. Right? We've got the two pairs of 14s, so 14 and 14, which is 2 times 7 and 2 times 7, and that's it. So we don't really have a huge list. So of these, remember negatives 2 because multiplying to a positive. So negative 14, negative 14. That's going to be our golden ticket. So if we were to write this out, it would look something like this. 2x squared. Ooh, let me move this over so you can see it. So 2x squared. We're going to take that negative 28 and split it. Negative 14x minus 14x. Okay, and then plus 98. So this is called factor by grouping. And what we're going to do at this point, we're going to essentially treat this like two separate things and look for the biggest common factor or the greatest common factor. So on the left, that's going to be a 2 and an x. And it's going to leave behind an x minus, if I take the x away and I divide this by 2, x minus 7. This side, I can take out a negative 14, leaving me with an x. 98 divided by negative 14 is negative 7. So if we do this right, the value in these two parentheses should be the same. So I'm left with an x minus 7 and a 2x minus 14, right? This has a common factor because we missed it at the very beginning. So x minus 7, and take the 2 that I divided out and stick it in front. And we'd have the same thing. Now, there's lots of times when you're going to use this factor by grouping method, and there was no common factor over here. Okay, you just had no choice but to do factor by grouping. So you would do it this way, and there wouldn't be this funny little step at the very end. All right, so that's a lot of information in one quick video, but somewhere to start in terms of looking at polynomial expansion and factoring.